These are notes for 5.3 on solving differential equations. In the first two objectives, we've been talking about just integration methods, and so we're going to continue on with that, but we're going to build onto it as well. So I've set up for you some problems here, the steps for solving, and what's going on. So a differential equation is really just the equation of the derivative. So you have your equation of a function. If you took the derivative of that, you'd end up with the equation of the derivative, y prime equals, or dy dx equals, or f prime of x equals. And what we're doing is we're starting with equations this way, and what we want to do is get back to y or f of x equals by integrating each side of the equation. So in our steps for solving, it's pretty simple. It's really just going to be a lot of setup and getting it ready to be integrated. So one of the biggest things that you have to do is separate the variables. You want your y's on the left and your x's on the right. You can see in problem number 1, the only thing we're going to have to do first is move dx over to the right side. The next step will be to integrate on both sides. We actually want to show the integral on both sides after we've separated the variables. And then remember to add c. The last step will be to simplify, and again, we want it in that y or f of x equals form. All right, so of course there'll be some other problems, maybe some cleanup before we can start integrating. There might be some use substitution on the way. So we're going to start with step 1 here, which just says to separate the variables. So my goal is to move dx over to the right, and I'll do that just by multiplying it over. All right, step 2, I want to show my integral on both sides and then integrate each side. So I can see that both sides appear to be ready to go. So we're going to add in our integrals here. Now you're integrating each side individually. The left is with respect to y and the right side is with respect to x. The left side should look familiar. We had a problem like this in objective 2. What we're really doing is integrating 1 with respect to y, which will give us y plus c. So we don't want to forget our plus c here. On the right side, we're going to integrate here, just each term separately. So we're going to keep our coefficient. We're going to increase the power of 1/2 by 1, so it's 3/2. And then remember, to divide by 3/2 is to multiply by 2/3. So we move on to the next term. We keep our -5 coefficient. We add 1 to our exponent here, so we get 5/2. And then to divide by 5/2 is to multiply by 2/5. And last, we want to include our plus c. So in simplifying each side, we're just going to worry about simplifying our coefficients here and then combining our constants. Now the biggest thing you have to get used to here right away is that each side, I might have written plus c, but this is not like writing x. It's not representing the same value each time. This is a constant on the right side and a constant on the left side. So the constant of integration for x and the constant of integration for y. These do not have to be the same c values. You can imagine this as being c1 and c2. Okay. In other words, I'm going to subtract this constant over here to the right side, and when I do that, I just end up with another constant, a c3, if you will. Okay. We simplify the two terms in front, so this is 2x to the 3/2 minus 2x to the 5/2. We have our plus c, and that's our equation. All right, so we're going to repeat this on problem number 2, which is a little bit different. You'll notice, besides the fact that it's got t instead of x, which is fine, we're going to keep y's on the left. We want t terms on the right, but it's going to need a little prep work before we can start our integration here. So I do want to multiply dt over to the right side, but before I can even start integrating, I'll have to simplify the right side. So what I'd like to do here is pull apart my fraction. Remember, we're going to take this common denominator and we're going to split up the fraction. So this is 2t cubed divided by t And over here, we're going to write this as t to the 1/2 divided by t. So just splitting that up and then simplifying each one so that it looks similar to problem number 1. So I now have dy is equal to, on the right side, 2t squared plus t to the power negative 1/2, since 1/2 minus 1 is negative 1/2. And then we'll still have our dt here. All right, so now it looks more like problem number 1, and we can show our integrals. So on the left, we're going to get y plus c is equal to, on the right side, 2t cubed divided by 3 plus t to the power 1/2 times 2 plus c. So the last step is to just simplify and combine our constants. So I'm going to subtract this constant from this one. We get y is equal to 2/3 t cubed plus 2, I can write this as square root t, t to the 1/2, or square root t, plus c. Now you can leave that as the fractional exponent or rewrite it as the square root. Right, just remember to combine your constants into 1. So let's move over to problem number 3, which is a little bit different. You can see we have some grouping symbols here for x minus 1, which typically means we're going to need some substitution. You'll also notice it's not written the same way at the beginning. There's no dy dx like we had over here for separating our variables. Since separating variables is a big deal, and notation with integration is also a big deal, you actually have to rewrite this y prime as dy dx first. So we're going to change that, dy dx, and then we'll move dx over to the right side. Now, besides that, this problem is not quite ready to integrate because I can't integrate with a product. So I'm left with having to figure out something else I can do, and that's going to be u substitution. So we're going to grab color here for the inside. Remember, we only want to let u equal the stuff inside, so u is going to be x minus 1. So on the side here, u is x minus 1. Now that only takes care of the stuff under the radical. I still have the leftovers to worry about. So I find what will replace the leftovers by taking the derivative here. So du, well, that would just be 1 for x minus 0, and then dx, 1 dx, or just dx. So that only takes care of the dx. We'll replace du with dx. We'll replace x minus 1 with u. So what about this x? It seems as though the substitution didn't work. But there is a trick you can use here. What we're going to do is take that u equals x minus 1. If u can replace x minus 1, then what can I replace x with? So let's solve this equation for x. Get x by itself. We're just going to add 1 over x is equal to u plus 1. And so now I have what x is in terms of u. And so I'll replace x with u plus 1. And this almost seems like it's not going to be enough to make this work. So let's try it out. So in the front, I have x, which is replaced with u plus 1. And then we have the square root of u. We're going to write as u to the power 1/2. And then last du will replace the dx. So was this enough? Just about. The only thing I need to do now is multiply this together. So notice before, the way it was written, you could not distribute x into the square root and do your integration that way. But this way, we actually can distribute u to the 1/2 into u plus 1, and we'll be able to integrate the individual terms that way. So we're going to rewrite it again. So this becomes u to the power 3/2 plus u to the 1/2 du. Sorry, I wrote dx. All right, and now it's set up for integration. So on the left, we'll have y plus c. On the right side, we have u to the power 5/2 times 2/5 plus u to the 3/2 times 2/3 plus c. In our simplifying step, there's really nothing to do with coefficients or the exponents, but we do have to replace u with x minus 1 and combine our constants. So the final step here, y is equal to 2/5 of x minus 1 to the 5/2 plus 2/3 of x minus 1 to the 3/2 plus c. All right, so in problems 1 through 3, it was pretty straightforward, just solving those differential equations. The last example that I have for you is just a little bit different. So problem number 4 here is write the equation for the explicit form for this differential equation g prime using the given initial condition g of 8 equals -11. So what's happening is the same thing essentially. They want us to take our differential equation, we want to integrate both sides, we want to get back to what g of x equals. That would be our explicit form. And then the initial condition here is going to allow us to solve for c. So this is a coordinate pair that exists on my original function, and it allows us to find the value of c. This will be our last step that we do with the problem. So once we have it down into this kind of simplified value with x's and y's, we can plug in x and the y value, and we can solve for the constant and write the actual equation. So we're going to start here by retitling g prime as dy dx. And then we're going to have to prep our equation here. So if you're okay with doing a couple steps at once, you can start doing that. So besides moving dx over to the right, we'll also want to rewrite our two terms so that they're ready to integrate. So I have now dy is equal to 8x to the power -2 minus x to the power 1/3, and then we've moved dx over here to the right side. So now we want to add in our integrals. So on the left, y plus c. On the right, we have 8x to the power, if we add 1 there, -1 divided by -1 minus x to the power 4/3 times 3/4 plus c. And this is really important. You want to keep going and simplify down to one constant before you plug in your coordinate pair. So I'm going to take this up to the side here. We get y is equal to, this is now -8 over x minus 3/4 x to the power 4/3, and then finally plus c. This is what our final answer will mostly look like, except we want to know the value of c. So we're going to use that coordinate pair now. So g of x, remember 8 is x, and it equals -11. So this is your y, because g of x or f of x is always y. So -11 is equal to -8 divided by 8 minus 3/4 of 8 to the power 4/3 plus c. So we hope that we did this right so that this value works out pretty nicely. This is -1 minus 3/4 of some number. So the cube root of 8 is 2. 2 to the 4th power is 16. And we just keep working on simplifying this. So 4 divides 16 4 times. -11 is equal to this is -1 minus 12, so negative 13 plus c. And if we add 13 to negative 11, we're going to get 2. So now we just take that back and plug it in here for our final answer. So we're going to write this as y is equal to negative 8 over x minus 3/4 x to the 4/3 plus 2. And that's our final answer. Okay, and that's all the notes for objective 3.